All right, let's dive into this. You've got an interview coming up with Johnson Controls. You've done the homework, you know your stuff. But now it's about turning all that knowledge into real confidence. That's exactly what we're going to do. Think of this as your final prep talk, so you can walk into that room ready to absolutely nail it.
So, you ready to ace this thing? Let's make sure you are. Here's our game plan. First, we'll cover what the company is all about. Then, we're going to lock down the core science and the key systems you really need to know. After that, we'll run through some of those tough questions you might get so you can feel prepared. And we'll wrap up with why you should be genuinely excited about this, and more importantly, how to show it.
Okay, first things first. Let's talk about what Johnson Controls really does. You know, anyone can read a mission statement off a website. You need to show that you get their vision for powering smart, sustainable buildings and, crucially, where you fit into that whole picture. This is the foundation for everything else.
Remember, Johnson Controls is a huge player in making buildings intelligent, so don't just talk about them selling HVAC units. You've got to frame your understanding around the bigger picture. They're creating these integrated ecosystems, from smart automation and all-air climate control to fire and safety systems, all designed to make buildings comfortable, safe, and, this is the big one, sustainable.
So you know what they do. Now let's get into the how. In this part, this is where you really separate yourself from other candidates. When you show a deep grasp of the fundamental science behind their products, it proves you're not just looking for a job. It shows you're an engineer who truly understands the core principles of the work.
This right here, this is the golden rule. If they ask you about fundamentals, this is where you start. The second law of thermodynamics is the why behind every single thing they do in cooling. The whole point of an air conditioner is just to cleverly manipulate this law. You're creating a really cold spot so that all the unwanted heat in the room wants to flow right to it where it can be captured and kicked outside. Simple as that.
This four-step dance is the heart of it all, and you need to be able to walk them through it clearly. Think of it like telling a story. First, the compressor squeezes the refrigerant gas, which makes it super hot. Then, that hot gas moves to the condenser coils outside where it releases all that heat and turns into a liquid. Next, here comes the magic trick. An expansion valve lets the pressure drop, making that liquid intensely cold. Finally, that super cold liquid flows through the evaporator coils inside, absorbs all the heat from the room's air, and poof, the room is cool. The liquid turns back into a gas, and the cycle starts all over again. It's a continuous, heat-moving machine.
Great. We've got the science down. Now, let's arm you with the specific systems and tools. Being able to talk about these by name shows you're ready to jump from the textbook theory to the practical, hands-on work of an engineer at Johnson Controls.
Okay, here is your chance to really impress. Almost every candidate is going to be able to explain vapor compression. It's the standard. But you can set yourself apart by also bringing up vapor absorption. Why? Because it shows you're thinking about alternatives in efficiency. Mentioning that these systems can use a heat source, like waste heat from a factory, instead of a mechanical compressor, well, that demonstrates a much higher level of thinking.
The psychrometric chart. I know, it looks complicated, but think of it as an engineer's best friend. Seriously, it's not something to be intimidated by. It's your ultimate cheat sheet for understanding air. It's the tool that lets you literally see how to change air from one condition to another, which, let's be honest, is the whole job.
Now, nobody expects you to have this chart memorized, but you absolutely need to be fluent in its language. You need to be able to talk confidently about things like dry bulb temperature, relative humidity, and especially enthalpy, which is the total energy in the air. Knowing these variables proves you understand what it actually takes to design an efficient system.
All right, it's simulation time. Let's take everything we've just covered and actually apply it to the kinds of tough questions you're probably going to get. You can bet you're going to get this question, or some version of it. They're not looking for a vague answer like, use less energy. They're testing you. They want to know if you understand the specific engineering principles that lead to real-world savings. Here's your toolkit for that answer. Start with variable air volume, or VAV systems. Explain that instead of just blasting fans at full speed all the time, VAV adjusts the airflow to match the actual demand. And then, here's the killer detail, connected to the fan laws.
casually mention that fan energy is proportional to the flow rate cubed. That means even a small reduction in fan speed gives you a huge energy saving. Tossing in other advanced designs like dual duct systems or UFAD just proves you're up to date with industry solutions.
When you get a question like this, it's a gift. Seriously. It's your chance to show them that you can take complex information and present it clearly and logically. The key is to give them a simple, powerful framework, not just ramble off a list of systems you memorized.
And here is that simple, powerful framework. You can explain that most of these big all-air systems really boil down to just two main designs, based on how the coils are arranged. You've got single duct systems, where the coils are in series, so all the air gets the same treatment. Then you've got dual duct systems, where the coils are in parallel. They create separate hot and cold air streams that get mixed together later on. Just using that series versus parallel distinction is an incredibly clear and impressive way to structure your answer.
Okay, you've proven you have the technical chops. Now for the final and most crucial piece of the puzzle, showing them you actually care. The end of the interview is your moment to connect all your skills to their mission and show some genuine enthusiasm.
And you should be genuinely excited, because this is your chance to work on things that really matter. You're not just engineering an HVAC system in a vacuum. You're helping Johnson Controls tackle massive global challenges like energy efficiency, sustainability, and making our spaces healthier. This is where you draw the line from your skills to a real, tangible impact on the world.
So, as you walk into that interview, I want you to hold on to this thought. You're not just there to recite the refrigeration cycle or define what a VAV system is. You are there to show them how your understanding of all these things will help them build the smarter, more sustainable spaces of tomorrow. Go show them what you know. You've got this.